Hi there. This video series is to display my problem solving and learning abilities. I plan to show that I can solve any programming problem, regardless of whether I already have expertise in a particular language. I hope this helps others in my field to learn not just how to solve a particular problem, but how to teach themselves a solution to an unfamiliar problem. Currently, I am learning Python. I have no professional experience in the language and have only been learning it since mid-January. My only formal training is completing the Python for Programmers course on Execute Program. While I'm picking Python up fairly quickly, I cannot claim any real expertise. Today, I'm vocalizing my thoughts while solving the 42nd Project Euler problem. As always, I will link to Project Euler and my repo in the description. Let's dive in. Problem 42 is coded triangle numbers. The nth term of the sequence of triangle numbers is given by t of n equals 1/2 of n times n plus 1. So the first 10 triangle numbers are 1, 3, 6, 10, 15, etc. By converting each letter in a word to a number corresponding to its alphabetical position, and adding these values, we form a word value. For example, the word value for sky is 19 plus 11 plus 25 equals 55. So if k is 11, and then j is 10. Okay. If the word value is a triangle number, then we shall call the word a triangle word. Using words.txt, a 16K text file containing nearly 2,000 common English words. How many are triangle words? Okay. So, I've already gone ahead and saved this txt. Let's go ahead and copy all of this right this second. Go and create our new file. So the last time we did work with a file like this was problem 22. Okay, and I'm not going to really bother with the formatting this time, honestly. Let's go back to problem 22. Okay. So in this case, we did sort these were names. We sorted them alphabetically. So that we could do a score times a position. Okay, but for this, we don't really have to do that. And actually, we probably don't want to bother with sorting when we don't need to. So, words, text, and then here I'm going to call this words. So now we have these words in an array. We have this alphabet variable here, which is just a string that's just all of the letters, but starting with an underscore because the underscore will be 0 indexed. Okay, this will be fine. These are already sorted. So I think what we want to do is calculate a bunch of these triangle words. Or calculate the triangle numbers. And I'm thinking if we go ahead and calculate, let's see. if we assume that, like, these words are all kind of, let's open that up again. Some of them are relatively long, like, unfortunately. So, let's see. I think the longest word we should, or the highest score for the highest word value we might expect, let's just assume that it's like 26 times 20, which would be 520. So if we calculate the first, first 100 triangle numbers, that should be enough. Let's go ahead and just do that. Let's say for n in range, 1, 2, let's go ahead and say 101, because I know it won't take hardly any time to go through the first 100 numbers. Trinum is equal to 1/2 times n plus 1. So I'm going to represent it as 0.5. Yeah, 0.5 times n times n plus 1. And then let's see, hold on. Okay, so 1/2 of 1 is 1/2. 1 plus 1 is 2. So that's 1. 1/2 of 2 is 1. For 2, 1/2 of 2 is 1. Times 2 plus 1 is 3. So 3. For 3, 3 plus 1 is 4. Half of 4 is 2. Times 3 is 6. Etc., etc., etc. Okay. Seeing it. So this should only be whole numbers, because either this will be an even number or this will be an even number. So I am going to go ahead and cast this product as an integer. And I am just going to go ahead and do trianglenums.append for that, instead of breaking it out into a variable. Might make it a little bit less readable, but like that's not the important part of this program. So I'm gonna go ahead and print out that triangle nums. I'm guessing that it's gonna be like way more than we actually need. Okay, so we got all the way up to 50/50. That should be, again, as I say, much more than we even need for this exact problem. Okay. So, now for every word in words, we need to find the word value. Triangle words equals 0. And then at the end, we want to print triangle words for W in words. Okay. And all of these are all capitals, so we don't have to worry about that at all. We might want to do more data sanitization, but since this is a very well-defined problem, we don't need to, so we're going to skip it. Now I'm going to look back at, okay, so I'm going to need to do that. And then I'm going to need to do basically the exact same thing as this. So, my old trick of just copy thing we've already done. And this, instead of score, I want to call it value. And I think I want to rename this word. It's not a big deal either way, obviously. Why do you not refactor for me? Oh. What if I do this? There we go. And then here, if val in triangle nums, triangle words, plus equals 1. And that should give us the correct answer. I'm unsure about exactly how efficient it will be, but it should be within our minute. Okay, it was within a second. It was within 1/100th of a second. Let's see if 162 is the correct answer. And it is. Okay, so just a quick recap. We created this alphabet string, so every letter of the alphabet is at the index that it is in the alphabet. So, like, to account for 0 indexing, we start with a space. A is at index 1, B is at index 26. We opened and read our file. I actually want to move this down just for better flow. And I also want to rename this to try word count, just to make it a little bit clearer that we're counting. Obviously completely unnecessary, shouldn't make any difference. We went ahead and we calculated the first 100 triangle numbers, operating under the correct assumption that that should be all we need. Like, to get a number that has a 5,000 score, to get a word that has a value of over 5,000 doing it like this, you would have to have like 200 Z's in a row, and English words just aren't normally that large. Forget how many letters are in the longest word in the Oxford English Dictionary, but I don't think it's over 200. And these are all common words. Common words tend to be a bit shorter. So this was an educated guess, but based on my knowledge of the English language. And then, of course, we open our file. We read in our file with this using F, which apparently we don't have to import. F is just file. We used open, which we don't have to import. And then we created a count variable. We went through every word in our words list. We stripped out the double quotes, which we could have done with some fancy, like, list comprehensions, I think, but this is just as good and just as easy to understand. Start with 0, go through every letter in the word, look up our index, which is our value, calculate that total, and then if the value is in our list of triangle numbers, we just add it to the count, print out the count. That's the answer to our problem. So, pretty simple one. Obviously, we went ahead and we got the correct answer first try. So, I'm going to call it there for today, and I'll see you in the next one.